Hi, welcome to my channel Icon Teacher. I am Satyaprasad. In this session, you will learn the representation of sets in the roster form or tabular form and also in the set builder form. Also in this session, you will learn the different types of sets. Okay. So to begin with, let us see the representation of sets. So in the representation of sets, we have basically two types of representation. So the first method is called as the roster form or tabular form. So in the roster form or tabular form, what we do is we list down all the elements within the braces separated by commas. So let us take a small example. Let set A equal to set of all natural numbers less than 5. So the set of all natural numbers less than 5 are nothing but 1, 2, 3 and 4. So we list down all the elements 1, 2, 3, 4 separated by commas within the braces. So this method of representation is called as the roster form. Let us take another example. Set of all prime numbers less than 20. Set of all prime numbers less than 20. So the prime numbers which are less than 20 are 2, 3, 5, 7, 11, 13, 17 and 19. So we write all these elements separated by commas within the braces. So this method of writing is called as the roster form. So this is one of the way we can represent a set. Now let us see the other ways of representing the set, that is the set builder form. Before that, we have few points to be noted. So if you see set A in the first case, which is set of natural numbers less than 5, we got A equal to 1, 2, 3, 4. Now instead of writing 1, 2, 3, 4, suppose I write A is equal to 1, 3, 2, 4. So still does it make the same sense? Yes, it still makes the same sense. So we can write the elements of set in any order. So whether you write 1, 2, 3, 4 as set A or 1, 3, 2, 4 or 1, 4, 2, 3, it still means the same. Okay, so that is the first point to be noted. Next, in the second point, we see that if any set contains the elements with repetition, it is same as writing the elements without repetition. That is, we write only the distinct objects. So 1, 2, 3, 2, 2, 1 is written as only 1, 2 and 3. So we write it as 1, 2 and 3. So we write all the distinct elements as 1, 2, 3. So these are the 2 points to be noted. The first point is that the elements can be written in any order, and the second point to be noted is that if the elements in the set are repeated, we have to only list down the distinct elements in the roster form. I hope the roster form is clear. The other way of calling the roster form is the tabular form. Right. Now let us come back to the next form, that is the set builder form. So in the set builder form, what we do is we write a common property associated with all the elements of the set. So let us see how to write the set builder form. So let us take a small example. Consider a set B containing the elements 1, 4, 9, 16, 25, 36 and 49. So in this set, you identify what is the common property of all these elements, and we found that they are nothing but the perfect squares. So and then we also observed that these numbers are less than 50. So this is having a common property that all these are the perfect squares which are less than 50. So we can write this as the set of all x such that x is a perfect square less than 50. So this is how we are going to do the set builder form. So the set builder form has certain rules. So let us see clearly how to write down this. So we x or y, anything we can write, and then we put a colon and then write the common property associated with the set. So here it is, x is a perfect square less than 50. So x is a perfect square less than 50. and we close the braces. So how do you read this as is, we read it as the set of all x, the set of all x. Here the variable I have written is x, so it's set of all x, and this colon stands for such that, and then we write the common property which is associated with the elements of the set. So the common property associated is they are all the perfect squares which are less than 50. So this is a common property. Common property. So these are the things we should keep in mind when we are writing the set builder form. So in the set builder form, first of all, for the given elements we have to identify what is the common property possessed by all the elements by which they are all together. So that property has to be written in the braces, but we have to start with opening the braces, write down the variable, and then we read it as the set of all the variable whatever written with colon, which means such that, and then we write the common property. Suppose we have multiple properties to be written, then we put comma and write the second condition also. And then let's take another example. Say let a equal to 2, 4, 6, 8 and 10. A equal to 2, 4, 6, 8 and 10. So identify what is the common property associated with 2, 4, 6, 8 and 10. So if you observe them, they are nothing but they are all even numbers which are less than or equal to 10. So we can write this a as a is equal to the set of all x, such that x is an even prime number. So x is an even natural number, and we observe that they are less than equal to 10. So less than equal to 10. The set of all x says that x is an even natural number less than or equal to 10. So the second example is set b is 1, 4, 9, 16. So we can write b as the set of all x says that x is a perfect square less than or equal to 50. So I hope you understood what is the set builder form and how to write the given set in the set builder form. Now the problem can also be solved in different way. So let us write down the set builder form in different way other than how we write in terms of the description in terms of words. So let us take the example. A is equal to it's given 2, 4, 6, 8, 10. 2, 4, 6, 8 and 10. So this is having a common property that they are all even numbers less than or equal to 10. So we can write the same as the set of all x such that instead of writing in words, what we write is we write x is equal to 2n, where n belongs to natural numbers, because here we observe that x is an even number, so 2 times n will always be a natural number and n is less than or equal to 5. So here it means a 2, 4, 6, 8, 10 is written in the set builder form as the set of all x such that x is equal to 2n, that is they are all multiples of 2. From where to where? From the value of x is taking x equal to 2, that because if n equal to 1 then we get 2 into 1 as 2. If n is taken a value 2 then 2 into 2 is 4, and if n equal to 3 we get 2 into 3 is 6. And if n takes a value 4, we get 8, and if n takes a value 5, then we get the value of x as 10, because we are saying x is equal to 2n. So this is the alternate way of writing down the set A in the set builder form. Already we have seen in the previous case that it can be written as the set of all x such that x is an even natural number less than or equal to 10. Here instead of writing in words, we have written as an equation x is equal to 2n, n belongs to natural numbers, n less than or equal to 5. Similarly, we can also write b. So here b is given to be the perfect squares 1, 4, 9, 1, 4, 9, 16, 25, 36, 49. So these are the elements given 1, 4, 9, 16, 25, 36 and 49. So this can also be written as an equation. So let's see how to write this. The set of all x such that instead of writing in word form, what we write is the set of all x is that x is equal to n square, because they are all perfect squares, where n is a natural number and n is less than or equal to 7, because 7 square is 49. So the set of all x is that x is equal to n square, n belongs to natural numbers, n less than or equal to 7. So if n takes a value 1, we get 1 square. If n takes a value 2, we get 2 square. N takes a value 3, it's 3 square. So on till if n takes a value 7, it is 7 square. So we can write the set builder form as the set of all x such that x is equal to n square, n belongs to natural numbers, n less than or equal to 7. I hope all of you understood how to write down the set builder form in this way also. Now let us see the different types of sets. The first type of set is an empty set. A set which contains no elements is called as an empty set. So in the empty set we find that there are no elements, so we write it simply with null set or empty braces. So empty set is a set which has no elements. It is also known as the void set. Now let us see some examples of empty set. Let A be a set, the set of all x such that x belongs to z and x square minus 2 is equal to 0. If x square minus 2 is equal to 0, then we get x square minus 2 equal to 0, which implies x is equal to plus or minus square root of 2. But here the condition says that x is an integer, and we know that root 2 or negative root 2 is not an integer. So the condition x square minus 2 equal to 0 is giving two values of x which are plus or minus root 2, but since both of them are not integers, so the set A is nothing but the null set. So we can write A as null set, like the symbol phi, phi, the symbol phi, or it can also be written as an empty within the braces, nothing is written, so empty braces. So this is how we represent the null set. Okay. Next, the other example for the null set could be the set of all x such that x belongs to natural numbers and x lies between 3 and 4. So since we know that there is no natural number between 3 and 4, so once again this gives us the answer as null set, because there is no such element which is a natural number which lies between 3 and 4. So the answer is null set. So in fact, whatever answer is something like it is impossible in your mind when we solve the problem. So if the answer is impossible, that means it will be resulting to a null set. So the next type of set is a singleton set. So we have seen what is a empty set or null set. The second type of set is a singleton set. So singleton set means a set which contains exactly one element. It is called as a singleton set. So let us take an example. The set of all x, x is an even prime number. So we know that there is only one even prime number, that is 2. So A equal to the element 2. Since there is only one element in the set, we call it as a singleton set. So another example could be the collection of all the natural numbers less than 2. So there is only one natural number less than 2, that is 1. So that could be another example for a singleton set. Next, another example. The set of all x, x is a whole number and less than 1. So the only whole number which is less than 1 is 0. So here we can write this as a singleton set which contains the element 0. Well, now let us see a thought-provoking question. Is null set within the braces an empty set? Many people do this mistake. So one should be very careful that within the set, if any element is written, then it is no more a null set. So remember, within the braces, if we write any element, even if you write a null set, that means it contains one element, that is a null set. So it is no more an empty set. Remember, the empty set will be either with phi or with empty braces without writing anything within the braces. But if you write any member within the braces, then it is no more a empty set. In fact, it becomes a singleton set. So this is containing one element. So this is an example of singleton set because this set contains one element, that is 5, whereas these two are the empty sets. But if you write 5 inside the braces, it is no more an empty set. In fact, it becomes a singleton set. So these two represent the empty sets, or also known as void sets, and this becomes a singleton set. So what we have to remember is, within the set, when we have one element, it is called as a singleton set. So that element could be in different forms. It could be like a set within another set, but still it is a singleton set. For example, suppose I have set A, which contains a set that contains 1, 2, 3 and 4. So here if we observe, set A contains only one element, which is in the form of set. So 1, 2, 3, 4 within the braces is only a single member which belongs to set A. So one should understand that there is only one element within set A. So we call this also as a singleton set. I hope you understood what is a singleton set. Now let us see the next type of set, that is finite set. So already we have seen in the number system the different types of numbers, like natural numbers, whole numbers. So they have infinite number of elements. So like for example, natural numbers 1, 2, 3, 4, so on. So if the set contains infinite number of elements, then it becomes an infinite set. And if the set contains finite number of elements, it is called as a finite set. So the different examples for finite set are set A containing 1, 2, 3, 4, 5. So they have limited number of elements or finite number of elements. So set A is equal to 1, 2, 3, 4, 5 is a finite set. So I hope you understood what is a finite set. So in the finite set, the elements are limited in number or countable number of elements are present. So the example for infinite set will be set of all natural numbers and set of all whole numbers. That those could be examples of infinite set. Then similarly, set of points on a line. All the points on a line, there are infinite number of points on a line. So that could also be an example of the infinite set. Next, we have something called as equal sets and equivalent sets. So to understand that, first of all, let us find what is the meaning of the cardinal number of a set. So let us write down what is cardinal number. Cardinal number. So cardinal number is nothing but the number of elements in a finite set. So the cardinal number is the number of elements in a finite set. So for example, set A has A, E, I, O, U. So we can write n of A is equal to, count the number of elements, we have 1, 2, 3, 4, 5, A, E, I, O, U, 5 numbers. So n of A is equal to 5. Similarly, suppose we have B to be a null set, then how many elements are there in null set? There are no elements in null set, so the cardinal number of B is 0. So the cardinal number is nothing but the number of elements in a finite set. Now let us see the other type of sets which are based on this cardinal number. Okay, so those are nothing but the equal sets and equivalent sets. Now let us take an example of equal sets. So what are equal sets? Two sets, if they have the same elements, then we call them as equal sets. If two sets have the same elements, then we call them as equal sets. And what are equivalent sets? If two sets have the same number of elements, then we say that they are equivalent sets. So this is the difference between equal sets and equivalent sets. So let's try to identify with some examples. So let's say A is a set which contains the set of all x X is the letter of the word follow. So X is the letter of the word follow. So which will be nothing but, let us write down in the roster form. We get F and then O and then we get L and W. So I hope you remember that whenever we have this letters of the word, we should write without repetition. So we write only one time. So we got F, O, L and W. And let us take a set B, which is the set of all x such that X is the letter of the word wolf. So B represents the letters, so it contains the elements W, O, L and F. So we found that A and B has the same elements. So W, O, L, F and F, O, L, W. So as I told you, the order is not really important. So A and B are having the same elements. So we say that A and B are equal sets. So A is equal to B. A is equal to B. So we can call that A and B are equal sets. A and B are equal sets. A and B are equal sets. So in the equal sets, we found that the two sets will have the same elements. The two sets will have the same elements. Now let us see what are equivalent sets. Equivalent sets. Okay, let us take a set A which contains elements like 3, 5 and 7, and set B containing the letters A, C and D. So we have learned what is the cardinal number. So the cardinal number of set A is equal to 3 and the cardinal number of set B is equal to also 3, because even set B has 3 elements. So if set A and set B has same number of elements, we say that n of A is equal to n of B. So if n of A is equal to n of B, then we say that A and B are equivalent sets, and we write it as A equivalent to B. So this is the symbol for equivalent sets. So A and B are equivalent sets. Equivalent sets.